Seahawks fan is back, this time with a new hat. Go Hawks! That's right! Go Hawks! Yeah! People love the Hawks. We're going to be beating the Dolphins. Who cares about the Dolphins? They're just a bunch of fish. That's right. And I don't insult Dolphins. I don't care. Anyway, we're not really necessarily here to talk about football today, but go Hawks anyway. Woo! That's right. Here, let me take that off. Get down to business here. Talking about things. Guess what? I know for a fact, now that I'm getting a little bit well known on YouTube, I know for a fact we're getting a visit today. I stepped out at halftime to do this psychology lesson, and so let me just get this taken care of over here, and we'll see if we can await our guest. He should be here any second, but I'm going to talk about genetics. Because I'm TNT! Oh my goodness, you guys just keep popping in on me like that, scaring me. How you doing, Pete? Okay, but how you doing? You looking forward to going down to Florida? Playing the Dolphins? He likes gum. Don't really know what to say. But Pete, so I thought of something. You want to hear it?
Probably not, to be honest.
I'll take that as a yes. Anyway, you want to hear it, Pete?
I already said no.
Well, listen to this. When you go down to Florida, you know what you should do? You should call them fish. You should call the Dolphins fish and say, you guys are just fish. You know, like Seahawks eat fish?
That's totally stupid. I'm not going to do that.
What? Okay, well, all right then, Pete. Well, get back to your game, and thanks for stopping by. Cause I'm TNT! Yeah, Pete's just a little bit mad because he got fined $100,000 for not wearing a mask on the sidelines. So he's a little bit angry. He took it out on me. Anyway, that being what it is, welcome to psychology, everybody. And so we are going to continue talking about psychology, and specifically we are going to talk about genetics. Whoops, let me unfreeze that. And by the way, I'm not biased, but go Hawks! Who wants the Dolphins to ever win a game? Okay, maybe I'm a little biased. A little. All right, anyway, you guys, so genetics and behavior. Genetics and behavior. Okay, we talked last time about evolution and behavior. I heard that there was a soldier here. We talked about evolution and behavior and how evolution can guide our behavior and so on. What about genetics? Now, this is a little more significant for our behavior than perhaps evolution. But what about genetics? What about it? What about are our behaviors inherited from our parents? If you have shy parents and you're shy, have you inherited that or have you learned it? How could we tell the difference? I mean, how could we have nature and nurture? Remember, nature means what you're born with, nurture means what you've been raised into becoming. So if we're going to talk about a trait, a behavioral trait like shyness or extrovertedness or something like that, how are we going to determine what is what? I mean, we can't exactly pull babies from their parents and stick them in boxes and let them grow up apart from their parents. And, you see, and see if they turn out to be introverted like their parents. We can't do that. Plus, maybe it's the box that made them introverted. But anyway, so it's an interesting psychological question. And this is important because this is actually way more significant in evolution, because if we're going to say that a behavior is inherited, I mean, what if you have anxiety disorder or something like that? Or what if somebody has a depressive disorder and their parents, one of their parents or both even, have also suffered from it? Well, is that an inherited trait? Is that something which is genetically based? And if it's genetically based, we have a different measure or way to approach it. It's more of a medical model because there's something wrong with the genetics. But if it's a social thing, well, then maybe we can get you to rethink how you think about things and change the way you consider stuff. It's not based on your biology. And so, I mean, as far as traits are concerned, we know that we inherit a lot of things from our parents. I mean, if your parents are tall, you're probably tall. If your parents are short, you're probably short. If both of your parents have brown eyes, undoubtedly, almost, well, there's a 1 in 4 chance, I guess, if somebody has. But I mean, if you come from a long line of brown eyes and everybody has brown eyes in your family, well, you have brown eyes too. Same with the blue eye thing. Hair color, the physical sort of build. Some people are more prone to be skinny. Some people are more prone to be bulky, and so on and so forth. So we have no qualms about saying that there are many inherited traits that we get from our parents. But all of a sudden, when we start getting into the idea that our behavior is inherited, that's really hard. That's really hard to know. And we don't really, you can talk about you behave similar to your parents, but that doesn't mean it was inherited. That means you've just grown up socializing that thing. I mean, your physical appearance isn't a question about socialization. It's not like you're socialized and all of a sudden you have brown eyes because you hang out with people with brown eyes all the time. It just doesn't work that way. It's a different thing altogether. But anyway, so this is the question, and it's significant for psychology. It's certainly significant for psychology in terms of treatment of disorders. And so, unlike evolutionary theory, which is still relevant and valid, but it's just not as relevant, this is a lot more relevant. Okay? So, how much of a behavior is hereditary? That's the question. Genotype. This is just some terminology. Genotype, genetic programming of an organism. Okay? Phenotype is the organism's observable characteristics. So, for instance, if you have brown eyes, well then, you have the sort of dominant traits of brown eyes in your heritage. We can talk about that as the genetic coding, and then the brown eyes are the phenotype or the actual thing. And I'm sure you've talked about this in biology before, but a little bit of review doesn't hurt. There's our friend with the DNA. There he is right there. But anyway, okay, so you know that. Now here's some premises about behavior. Studying behavior and genetics. Premises, 50% of genetic material from each parent. So you share 50% of your parent. I mean, this isn't like a no-brainer, well, duh, obviously. But still, siblings, 50% possibility of having the same gene. Even any given gene, you have 50% of having the same gene as your sibling. So for instance, this is basically the idea, and we do know that something like schizophrenia is genetic. If you have a full brother or sister that has schizophrenia, then you are bound a 50% chance of getting schizophrenia as well. But there's a lot of other stuff too. How about shyness? How about intelligence? How about outgoingness? How about anxiety, ease to be anxious, and stuff like that. There's all kinds of personality traits. Whew. Go Hawks! I have to say that every time I sneeze. Otherwise, I'll just go in sneezing fits. How does genetic makeup and our environment affect our behavior? That's the question, nature or nurture. How do we distinguish between genetic influence and environmental influence? How do we go about doing that? And if we can find a way, then what do we find? And so anyway, I'll put this up there as well, right there. So you can see it a little bit better. And you certainly can't see it with a big football fan standing in front of it. But anyway, okay. So what you see there is, you see basically you share the same DNA with yourself, obviously, in a twin. I'm talking about a one egg or a monozygotic twin. But anyway, you see the thing there. You can basically read it. This isn't anything that's the 1/2, the 1/4, and that kind of stuff. That's just basically how much of your DNA you share with them. It's nothing we need to go over too deeply. It's just kind of a graphic representation of kind of how much we share with different people in our family. All right. Now, here is how we go about finding things. And one of the most important things for psychologists researching genetic behavior, and it's still going on, one of the most important things, the holy grail of personality behavior in regards to genetics is twins. And I'm not talking about fraternal twins, dizygotic. I'm talking about identical twins, monozygotic. Okay? And why is this so important? It's important, and the very best of all, the sort of pot of gold at the end of the genetic psychologist rainbow is identical twins that have been separated at birth. Okay, why is this so important? Well, because identical twins share the exact same genetic code. It's the same fertilized egg that splits into two. It's the same person that splits into two people. And so they share the exact same genetic material, the exact same. And so if we separate them, and if we find that even if they were grown up in different households, if they're very, very similar, then we have some support for the claim that personality is inherited. But if we take these same twins and we separate them and they grow up in different households and they're completely, totally different, well, then we can say, well, then it's nurture, then it's the upbringing that really causes the personality. And so what have they found? Now, this doesn't happen very often, okay? You had a bunch of different things there. First of all, not very many identical twins get separated at birth and raised in different households, right? That just doesn't happen very often in the first place. Most people who adopt would adopt a set of twins. But anyway, so that doesn't happen very much in the first place. And secondly, you have to have people that want to participate in the study, and the twin has to want to participate in the study, and they might not even know about each other. And if they're kids, the parents may not want this to happen. And so it really doesn't happen very often. And a lot of times what they'll do is they will study twins who grew up together and they know each other. So it's not as good as the other one, but it still works fairly well. But so that's the idea of how they really, really want to study this. And you can't really necessarily study just fraternal twins, because even though they're born at the same time, they're just a brother and sister. They're two eggs that got fertilized at the same time. So they're no different than any other brother and sister. You just share a birthday. But anyway, okay. So here's the ideas. We look for different things. Heritability coefficient estimates the extent to which the differences of variation can be attributed to genetic factors. They do adoption studies, like I talked about, the adoption studies where twins are separated and adopted. This is all in the PowerPoint that you guys have. Well, anyway, here's the general. Now, these studies, they did a whole bunch of studies. This isn't Minnesota twin studies, but they talk about Minnesota twin studies in the book. We're going to look at it more. The Minnesota twin studies are probably the best set of twin studies in the world, and they've been going on for years and years and years. And they follow twins. They're not separated at birth twins, they're identical twins, but they follow twins throughout life. I mean, for a long time, and they have a massive database of information about twins, and it's really, really quite good stuff. But anyway, so what they found when they looked at twins, okay? And here's another way that you can do it. You can compare twins. Now, if you can't separate people at birth, which you obviously can't, there's a few cases of it, and it's kind of interesting. But if you can't separate people at birth, well, at least you can compare it to other twins. You can compare it to fraternal twins. You can compare people's personalities, fraternal twins and normal brother and sister, and the identical twins, and see how similar they are, okay? So here's basically what they found in the studies, and this is from a guy named Lolan, Genes in the Environment, Personality Disorder down here, is that when they look at the personality similarities between identical twins and fraternal twins, what they find is, now, these blue lines, I'm going to put it up here, the blue lines up here, what they represent is the correlation in behaviors. It doesn't mean, like, the one up top says extroversion, so how extroverted, how outgoing somebody is. So it doesn't mean that the identical twins are 50% both outgoing. That's not what it means. What it means is that the similarity between the twins is higher. There's a correlation at 0.5% between the levels of outgoingness or extroversion. And if you look at fraternal twins, also raised together, there's only about a 10% or 20% correlation between the similarities between their extroversion. And so that's what those graphs are saying. They're showing specifically there's a higher degree of similarity between twins, identical twins that are raised together in their personalities, and fraternal twins that are raised together in their personalities. Now, it's not as good as separating them at birth, but still, it's a pretty good study. Neuroticism. Neuroticism means kind of, I guess, how easy you have to get sort of nervous and stressed out about stuff. That's neuroticism. Identical twins are more similar in that category of either easy or hard to get stressed out, whatever. Identical twins are much more similar in that category. Agreeableness, this one always makes me laugh. Agreeableness, yep, I agree, yep, I like it, yeah, you like it, yeah, it's great, okay, yep. So they're more similar in how agreeable they are. Yeah, we're agreeable, she's agreeable, yeah, I'm agreeable, we're agreeable. Then normal twins are like, he's agreeable, yeah, I'm not agreeable. Yes, you are, no, you're not. And so you see what I mean. And so conscientiousness, like being courteous, hello, after you, no, after you, no, after you, no, after you, no, after you, oh, this is getting silly, after you, no, after you. All right? And openness to experience, YOLO! Go Hawks! Whoa, now that I'm in the stance. YOLO, openness to experience, woo! Okay? So, and you see that they're more similar, of course. Okay? Now, this is also another interesting one, also from the same study. So, similarity of intelligence scores. Right? Put that one over there too. Okay? And it shows how similar people's intelligence scores are. It doesn't mean that they're like super smart. I mean, they could be similarly stupid, I guess. But it just means how similar their intelligence scores are. So the similarity between identical twins' intelligence who are reared together has almost a 90% correlation. It's very, very similar. Okay? And then you have identical twins reared apart. So they're separated at birth. And so, but we also see that that's a really high correlation. Even when they've been reared apart, that they have a high correlation between the similarity, but it's lower. You see that it's lower anyway, so that shows that the environment has some form of effect. Anyway, fraternal twins reared together, the similarity is lower. So normal brother and sister, the similarity between their intelligence, it's lower correlated even than identical twins reared apart. Siblings reared together, even lower. And I'm not really sure why that would be, since they're just siblings, but different life experiences at different times, different ages and things like that. And then unrelated individuals reared together. So if you just take, two random people off the street, reared together. Stepbrother and stepsister type thing. And they're unrelated, actually. And so you rear them together. They don't really have a very high correlation of intelligence at all. So what this is showing, and it's really rather interesting, is that you have evidence here that says both the environment and the inheritance, the genetic inheritance, actually make a difference in the intelligence. Because first of all, identical twins reared together have a higher correlation than identical twins reared apart, pointing specifically to the environment being a factor in that sort of correlation between intelligence. But still, as I said before, it's very important for that genetic thing. So intelligence seems to be an inheritable trait at some level. Okay, so that's actually really kind of interesting. Quite fascinating, really, to be completely honest. And so nevertheless, I'm going to take a look at, we're going to do some more stuff with the twin studies. This is a little bit of a shorter lesson, but I'm going to run through some other slides. And these are, I can get you the place where I got the information for these slides, but these are just kind of fun ones, really, to talk about. And some general sort of genetic differences between men and women are kind of fun to look at. It's not really, anyway, so these are just kind of some funny, interesting slides to take a look at. And how genetically men and women are different in personality and behavior and stuff like this. So I'm going to put all these here first, and then I'm going to do some form of like dramatization for moving them over there. So first of all, we have this one here. So, okay, so what do you see? The probability of consenting to sex with an anonymous stranger. Just an anonymous stranger. The dudes are like, is she hot? Well, okay. Anyway, so 20% of the, about 18% of the males said, yep. Well, wait, is she hot? But anyway, about 18% of the males said they would, whereas females were like, no, gross. Another almost 30% of the males said they probably would, probably, but depends, is she hot? And yeah, anyway, females, probably not. 30% of the males, and they only said that because they were with their girlfriend when they got asked. I'm making that up. Anyway, and then certainly not. Around 50% of the women said no way, absolutely not, and around 18% of the men said no, and they were definitely probably with their wife at the time. And also, I'm making that up just to be funny. Okay, so that's kind of an interesting sort of difference between men and women. So let's go to the next one. And I think I'm going to throw this one over there this time. I'm getting some ideas. Watch this. Okay, here we go. Pretty cool, huh? Okay, sex difference in ideal number of sex partners over a lifetime. So what do men say? What's the ideal number of sex partners over a lifetime for a man, and the ideal number of sex partners over a lifetime for a woman? Okay, so let's look. So we'll say lifetime, the time is on the bottom as you see there, okay? And then the number of sex partners is up top. And for men says, let's say for a 4-year period of time, men say, well, around 10. 10's pretty good. Around 10 is pretty darn good. And women are like, well, 2, maybe 3. And for a lifetime, men are like, for 20 years, men are like, well, 14 is a good number. Yep, that sounds good. 14, sure, 14 sexual partners over 10 or 20 years. Yeah, that sounds about right. That's a little less than 1 a year. That's a little more than 1. Yeah, a little less than 1 a year. So there we go. And then, so 17 for the lifetime for a man. And then only, what's that? 5 for a woman. And this is interesting. And I mean, when you have things like this, you show that there's like a genetic difference in the mindset between a man and a woman. I mean, it could be socialized, but it's, there's obviously some very big differences. Okay? Now, you know what I'm going to do for this one? For this next one, I'm going to, look at this, I'm going to kick it up there. Oh, boom! There it goes. So, sex differences in likelihood of agreeing to sexual intercourse. This is also kind of an interesting one. So how long does somebody have to know each other? Hang on a sec. Oh yeah, that's right. So it's kind of going in reverse. How long does somebody have to know each other before they agree to have sex with them? Is this difference, does a man need to know a woman shorter period of time, or a woman need to know a man a shorter period of time? And so the likelihood for a woman to have sex with a man after 1 hour is like, no, it's -3, whatever that actually represents, I'm not sure. It's certainly doesn't sound like it's a positive idea. The man's like, around -1. But anyway, once you get up to a week, the dude's like, well, yeah, it's one known a week. And the woman's like, no, I'm still floating around down here in like pretty much -3. What are you talking about? He's like, a week. And like, a month, look at that, a month. And you're like, well, I'm up to -2 in a month, but that's still a -2. Again, what does that actually mean? I'm not exactly sure. But the idea, you see the graph, it's like the woman is a lot less likely in a shorter period of time to decide to have sex with a man. All right, I should be facing over here. Although you guys probably do know, it isn't there right now. It's a trick of the trade. Yeah, editing. Yeah, go Hawks! That's right! Go Hawks, crush the Dolphins! They're fish! Even though Pete was sour about the joke. All right, so next one. This one makes me laugh every time I see it. Okay, minimum acceptable intelligence is experienced as a percentile. Okay? So, for a regular date, men and women want to have pretty much the similar level of intelligence to go on and date people. Okay? But for casual sex, the dude's like, yeah, it doesn't matter much. I don't really care. She doesn't have to be that smart. We're going to drop the acceptable level of intelligence to be able to have sex with this person. It's fine. She can actually be pretty stupid. And so that's what dudes are saying. And women are like, no. A date, I'll go out with a date on you, but you better be kind of smart. You better be even smarter than I thought you were on the date if I'm going to have sex with you. And so this increases steady date. They want more intelligence. As soon as you get into steady dating, men and women are about the same again. And then men are actually a little bit more demanding in the requirement for a marriage partner. They want somebody they view to be intelligent. Okay? And one last one. I think I'll do, you know what this one's going to be? This one's going to be a hook shot. There we go. Oh, there's two last ones. So, age range for men, and these two slides that go next, or hand in hand, are actually really quite interesting. Age range of female partners sought by men. Okay? And men, the average age, the age for the man and for the woman in the next one is at 0. It doesn't mean the person is 0 years old, but that's this line for the male. And what they're looking for is when men are 20 years old, they're willing to date somebody 5 years younger or 5 years older. Okay? Now, what a 20-year-old dating a 15-year-old, that's statutory rape, all right? But we're talking about that's a social societal determination that's too young to have sex for a 20-year-old. And it's not like that in every country around the world. And it wasn't even like that here. You were marryable when you were 15. Not all that long ago in this country. And so, maybe 80 years ago or something like that. But anyway, so you get the idea. When a man is 30, what you see is he wants somebody who's younger than him. A man is 30, he'll date somebody up to about 32, but he's really looking for someone anywhere between 20 and 30. When a man is 40, he doesn't even want to date women that are 40. He wants to date women that are all the way down to around 25. Even 24 would be all right. When a man's 50, he's like, no, I want to date someone around 35. And when a man's 60, I want to date someone around 45. So men are continually wanting to date someone who are younger than them. They're looking for women that are younger than them. Okay? And so you would think, well, that's kind of weird. But do women want men that are older than them? And most of your, probably, I'm guessing, most of your parents, your dad is probably older than your man. That's actually, your dad is probably older than your mom, sorry. And so that's kind of the norm. It's kind of, so people are attracted that way. But here's the other one. And this one's going to be a home run. So women, once again, the age is at 0. So when women are 20, they're like, there's no way on earth I would want to date somebody 5 years younger than me and then I'm 20. It's like I'm a woman, I'm grown up. That's a boy playing Minecraft. No thanks. By the time the woman is 30, 25, but up to 35, or up to 40. By the time the woman is 40, it stays about the same after that. A 40-year-old woman is willing to go down to somebody who's 35, but she's really looking for somebody older. So up to 50, and the same story, 50 up to 60, 60 up to 70. So the woman is looking for somebody older, and the man is looking for somebody younger. Now, this makes sense in some ways. A woman's brain develops faster than a man's. A woman's brain is fully developed by around 18 or 19. A man's brain is not fully developed until around 23. And so this makes sense. I mean, an 18-year-old woman, 19-year-old woman with a mature, fully developed brain trying to date an 18-year-old guy is really, in some ways you could argue, like dating a child, the 18-year-old guy, because the guy's brains are not developed. And the last part of the man's brain to develop is the emotional control centers and risk management. And so there's a reason that a lot of young dudes do a lot of stupid stuff. And there's a reason that young dudes are the worst drivers on the planet, because they don't have a fully mature brain in terms of risk management and danger assessment and emotional control. And so that's the last part of the brains to develop, and it makes sense in a biological reason why women would be they would find a mature man more attractive, because they don't want to date a boy. And so this kind of makes sense. And a lot of times women are looking for stability in relationships, and men who are older are generally a little more stable. But whatever the reasons are, this is just data. And so it's kind of an interesting thing to think about, kind of interesting, but it's clear that it's so common, that it's such a normal thing, the difference between men and women, that we can start talking about being genetic differences. And with that, guys, I think that my halftime is over. I need to get back to the game. Wait, you guys, I think I hear the crowd. Oh, yeah, there they are. And I'm gonna go watch them continue to stomp the fish. Seahawks eat fish. They do. So off we go. Off I go. Have a nice rest of your day. Go Hawks!